Hi there, welcome to my channel. My name is Wouter. I'm a physicist from Holland, and today we're going to discuss one of my hobbies, high school mathematics. Have fun. This is an empty plane. It has nothing, it has no distances, it has no directions. So let's do something about it. Let's draw two lines, one in the horizontal and one in the vertical direction. The horizontal is called the x direction, the vertical is called the y direction. And at the point where they intersect, that is the origin, or let's say the 0 point. So now we have the plane with directions, but we still don't have distances. So let's add a couple of points like this and add some numbers to them. So in the x direction, we have now 1, 2, 3. Is it kilometers? Is it meters? Is it centimeters? We don't know. But it's just units, right? So it's one step in the x direction, 2, 3 steps. Same in the y direction, but now we can also walk the other way. So let's go in the negative x direction, that is right there, and in the negative y direction, which is right there. And then there is suddenly an extra point right there. So now we need to know where is this point exactly, right? So you can already see that we have to move one in the x direction and one in the y direction with a bit of a curve. Sorry about it. So one step in the x direction and two steps in the y direction, right? So how do we denote this? How do we denote this coordinate? Right? So the coordinate for this point is x, y, 1 in the x, 2 in the y direction. So there you have it. Let's do another example. A point right here. I won't be drawing this time. 3 steps in the minus x direction to get there, and 1 step in the minus x direction to get there. So the coordinate for this point is -3, -1. All right, so then I would like to explain that the entire plane on which we have now imposed this coordinate system is subdivided in 4 sections. So we have this first section that is in the positive x and in the positive y direction. It's called the first quadrant. Then we have the second quadrant in the negative x, but still in the positive y direction. Third quadrant, negative x, negative y, and the fourth quadrant, negative y, but positive x. You might be wondering why, but you'll see later. So this is a zoomed in version of the coordinate system. You can see here only one step in each direction. Right? So we have the origin, one step in the x, only one in the y. The other steps do still exist, but we just zoomed in so that we can only see this version. All right, so as we have seen, if you have one step in the x direction, there can still also be a coordinate attached to that. If you have this point right here, right, this is one step in the x direction, but 0 steps in the y direction. So if you want to give this point a coordinate, it would look like this. 1, 0. Similarly, for the +1 in the y direction, it has 0 steps in the x direction and 1 step in the y direction, right? So I think it should be obvious now for the other points here as well. What we can do is we can draw a circle through all these points surrounding the origin. And that would look like this. Because this circle goes through all the points with a distance 1 unit away from the origin. This circle is called the unit circle, and it's the main topic for today's video. Okay, so some definitions. We have here the radius, which is half the width of the circle, so it's the distance from the origin towards the circumference. And then we have the full width, which is the diameter. Just definitions, there's nothing to understand here, just definitions, right? So then we have a point sitting on the coordinate 1, 0, and this point is going to walk on the circumference of the circle. It can do so in two directions. So we have the positive direction, and so this is the counterclockwise, and we have the clockwise direction, which is the negative direction. Also just a definition. Alright, so here we have the unit circle again, and let's imagine that we again start here, walking in the positive direction. Okay, at a certain moment we end up here at point P, and you can see that point P, as does every point at the circumference on the circle, has a distance of 1 towards the origin of the circle. All right, but also you can see it has a certain angle. Let's call this angle alpha with the x-axis. All right, so if we would not have walked at all, so if we would still be here in this point, then there would not be any angle with the x-axis, so the angle would be 0 degrees. But now, as we are walking in the positive direction, we landed in point P, but if we would continue, then here on the y-axis, we would be at 90 degrees. So why is this 90 degrees? There is no good reason. It just is. It's definition, right? So we call this 90 degrees. Each quadrant of this plane covers an area of 90 degrees. So this first quadrant goes from 0 to 90 degrees. The second quadrant goes from 90 to 180. The third quadrant goes from 180 to 270. And the fourth quadrant goes from 270 to 360 degrees. So in a sense, if you end up at 360 degrees, you have completed a full circle and you're back at your starting point. So here you can see point P is somewhere between 0 and 90 degrees. I think it's closer to 90 than to 0. So maybe something like 70 or something close to that. If we continue walking on the circumference, we wind up at point T, right? This point also has a distance of 1 to the origin, unit circle, but then it has a different angle with the x-axis. Let's call this angle beta. Also again a Greek character, which is usual. We walk further and we wind up at point K, which has, for instance, an angle named gamma. So as you see, it is normal to indicate points with a capital, in this case P, T, K, and angles with a Greek character, alpha, beta, gamma, and so on. But we have been walking in a positive direction, but we can also walk in a negative direction. So let's do that right here until we wind up at point Q. Alright, Q, so since we were walking in a negative direction, also the angle towards the x-axis is negative, and in this case we're calling it minus theta. Alright, so let's stick to this point P. Here you can see that we have still 0 degrees here at the x-axis, 90 degrees here, But now next to the degrees, I also put the actual coordinates of these points. As you know, the x coordinate of the point on the unit circle is 1.0, 1 comma 0, and in the y direction 0 comma 1. All right, so we want to know what are the actual coordinates of this point P. Okay, so then we need to know how far do we need to walk in the x direction and how far do we need to walk in the y direction in order to end up there. So we have here, we need to walk a distance which we don't know exactly at this point, but the distance I will call for the moment the x of P. And then once we end up here at this point, we need to go in the y direction, which is this distance all the way up to y. So now the coordinate of point P is xp in the x direction, which is, okay, we'll see that later, and yp in the y direction. Okay, so we need to find a way on how to calculate this. And now we end up with a calculator. If you know the angle, you can find the xp by typing in the cosinus of this alpha angle, and you can find the yp by simply typing in sinus of alpha. I think sine comes from Latin, means wave or something. Not sure about it, so write it in the comments if you know. It's interesting. I can look it up myself as well, of course, but you might beat me at it. Okay, so the cosinus of alpha is this distance. The sine of alpha is this distance. So what is it in this case? We cannot calculate it because we don't know the exact angle alpha. But we can see already. So if you look at xp, it looks like something about half-ish, maybe a little bit less, I don't know, somewhere halfway. And the sine is almost 1. Okay, so once we're going to start with actual calculations in the future, it is always important to have an eye on the unit circle yourself in order for you to be sure that whatever you're typing in your calculator is correct. So if you type in this alpha here and for the xp, you get a number of 0.47, you know that you're probably right. If you get a number of 17.83, you're probably wrong. Have a quick summary of what we have seen so far. We have the quadrants in the so the first, second, third, and fourth, as you've seen in the first slide. Then we have the definitions of a radius, which is the distance from the origin towards the circle circumference. Here you can see it as depicted as the distance between the origin and the point on the unit circle that crosses the x-axis. And the diameter is the full width of the circle. Then we have the positive and the negative directions in which we can walk along the circumference. Then we have had a look at the angles from 0 degrees to 360 degrees. And the angles are usually denoted by a Greek character. And finally, the coordinate of a certain point on the surface can be found by calculating the cosine of this angle for the x coordinate and the sine of the angle for the y coordinate. Okay, that's gonna do it for today. Thanks for watching. Alright, that's gonna do it for today. I hope you liked it. I hope you got any of it. I hope you enjoyed it. If so, please leave a like. If not, then please also leave a like and consider to subscribe. In the next video, I'm going to add a bit more calculations to the topic and hope to see you there. Until then, have a good one.